Okay, we will now discuss how we could possibly use the Pythagorean theorem in problem solving. So just remember the formula for our Pythagorean theorem, which is generally a squared plus b squared is equal to c squared. And from there, you can already derive the other formulas when you are looking for the missing side. Okay, so let's look into this first problem. Two cars starting from the same point are heading to different directions. One travels east for 9 kilometers and then stops. The other travels north for 40 kilometers and then stops. How far apart are the two cars when both of them come to stop? So this is a certain problem where you could actually use your knowledge on Pythagorean theorem. So here, what do we have? There are two cars who are heading to different directions. One is uh, going east. So that means to say if this is the starting point, so let's just have this as the starting point, which is now your point S. Now there is one car which is heading east and it travels for 9 kilometers and then stops. So we will just draw a line for that one. And this pertains now to that 9 kilometers. So we will now have that as our car 1. Okay, that is now our car 1. And then the other travels north for 40 kilometers and then stops. So there is another car which travels and that is north. So that must be this direction. Okay. So if it's 49 and 40, that's quite longer than the 9. Okay. So if you are going to do that, this is now the position of the other car. So let's just have that as our car number 2. Now the thing here is how far apart are the two cars when both of them come to stop. So the problem is actually asking us for the direct distance. So this is now the distance that we are trying to figure out. So as you notice, we are able to form a right triangle. So again, it is very important that we are able to analyze the problem that we are dealing with. So therefore, this we can say that this is now 9 kilometers and then the side or this one will be 40 kilometers. And so since we have this as your right angle, we know that this is the side which is missing and that is the opposite side, and we will let this now be the hypotenuse. Okay, so I will just name that as our C. And going back to our formula, your C squared is again equal to A squared plus B squared. Okay, so from there we can just substitute. Anyway, there's no difference even if we interchange now the places of your numbers 9 and 40. Okay, so I will just go to that one, 40 as our altitude in the representation for your triangle, while the 9 now being the base, so 9 squared. So what do we have here? 40 times 40 is of course 1,600, and the 9 squared is equal to 81. So 9 times 9 is 81. And of course, adding this, that will result now to 1,681. And if you are going to extract the square root, so again, this is your C squared, but what we want is the value of C. Therefore, we need to extract the square root of 1,681, and the answer that we are getting is 41. So we have now the direct distance between the two cars is equivalent to 41. And do not forget the importance of the unit of measure which is involved, and that is kilometers. Okay, so that is the answer for our first problem. Okay, let's have another problems involving your right triangles and with the use of the Pythagorean theorem. So a ladder 5 meters long leans against a wall. The foot of the ladder is 3 meters from the base of the wall. How far can the ladder reach up the wall? Okay, so here there is a certain ladder which is leaning against the wall. So a ladder 5 meters long would say that there is a ladder which is 5 meters long. So I can say that this is now the ladder which is 5 meters long. And then, of course, this will be considered now as the wall, okay, where the ladder is leaning to. And from there, we have the statement here. The foot of the ladder is 3 meters from the base of the wall. So I will be considering this as the foot of the ladder, this point. Okay? This is now the ladder that we have. And then that is 3 meters. Okay, this is now the 3 meters from the base of the wall. So again, this is now the wall. I will consider now this as the base of the wall. Okay, and the next thing that we will do now is to put those measurements. So I have 3 here, 3 meters, and then we have 4 meter or 5 meters as the length of your ladder. And therefore, okay, we know the Pythagorean triple, 3, 4, and 5. So we can automatically say that this is equal to 4 meters. Or if we want to solve that, remember we will be putting now the right angle here, which means that it is the altitude that we are actually looking for. So we have now the altitude being a raised to the second power is equal to 5 squared, which is the hypotenuse, minus the 3 squared. So if you are going to continue with this, 5 squared is equal to 25, and 3 squared is equal to 9, and this will result to 25 minus 9 is 16, and extracting the square root now of 16, that is equivalent to 4. And since the unit of measure being used is meters, we just have to write that also. Okay, and that is how high. Okay, so the question here is how far can the ladder reach up the wall? So that is now 4 meters. Okay, again, that's another application of your Pythagorean theorem. Okay, here is another problem. A circle O, or a circle center O with a radius of 7 cm has a chord 10 or AB 10 centimeters long. Now find the perpendicular distance from O to AB, giving the answer to 2 decimal places. So let's try to represent first, or to try to draw and figure out this problem. So what do we have? We are dealing with a circle, okay? And we know that once you name your circle, we always name that circle based on the center, and the center is O. Okay, so again, we have a circle with the center O. Now, with a radius of 7 centimeters, so the radius is equivalent to 7 centimeters. So again, the radius is the distance from the center to any point on the circle. Now, there are there is a chord here which is 10 centimeter. Okay, so I will be having a chord. I will try to draw now a chord which is 10 centimeters long. Okay, so there, if I will have this as our chord AB, that simply means that this is point A and then point B. So by definition, when you say chord, it is a line which connects 2 points on the circle. Okay, a diameter is also a chord, or is also a chord. It's just that it's a special kind of chord because it passes through the center, and we cannot have that because it is not equivalent to 14. Okay, so if you have 14 as the given chord, that means that is the diameter. It so happened that your AB is equivalent to 10, so the length of this is 10. Okay, and then the radius is 7. So remember, if I will be doing now, if I will draw a certain line connecting now your circle O, or the center to your A, that is equal to 7. And also, if I will be doing it here, okay, so the radii of circles are always equal or congruent. So that means this will be 7, and definitely this will also be 7. Now the question is, find the perpendicular distance, or yeah, perpendicular distance from O to AB. So the one that we are actually looking for is this line. Okay, it is the line which is the perpendicular distance. So when we say perpendicular lines, they should be forming right angles. Correct? So we have here now the right angle. So it's either we use any of this. Okay, but remember, the chord is equivalent to 10. So what are we going to do? We have now a 7. So since these two are equal, okay, we can now say that this must also be of equal distance. So I will now just divide the 10 here, which is the chord, to 5. So I will make this one 5, and the other side also as equivalent to 5. And that will be the one that we will be using because we are now dealing with this small triangle, right triangle. The one that we will be dealing with, if you have this 10, 7, 7, it is an isosceles triangle. Okay, so we cannot use the Pythagorean theorem in that sense. So again, when you say Pythagorean theorem, it's limited to right triangles. So if you are going to look into this, and if you have this as the hypotenuse, again, we will just have, okay, so this is now the perpendicular distance. I will just have that as our altitude is equivalent to, or a squared is equal to c squared minus your b squared. Okay, so if you are going to continue with this, your c squared is immediately equal to 7. So 7 squared minus 5 squared. And 7 squared is, of course, equivalent to 49. And 49 minus 25. Okay, and the answer that we are getting here is equal to 24. Now, aside from in the form of a decimal class, you can also have, instead of the square root of 24, so again, this is now your a, which is the square root of 24, you can just simply rationalize. So how do we do that? The factors of 24 with the perfect square is 4 multiplied by 6. But since 4 is a perfect square, you can have that as 2 and then square root of 6. Okay? But if you want it in decimal form, you could just have the square root of 24, and the answer that you will be getting there is 8 point or 4.89. Okay? Again, the answer that you will be getting there is 4.899. So we could just have that 4.9. Okay. And that is, of course, the unit of measure that was used is centimeter. Okay. So we know now that the perpendicular distance from from your center O to your chord AB is equal to 4.9 centimeters. So those are some applications of your Pythagorean theorem when you are dealing with your right triangles.